So hexane has a density. Actually, I'm just gonna write it all out. So hexane density of 0.766 grams per centimeter cubed. Perfluoro-hexane. So it's kind of like hexane, but without, instead of carbons, they have some fluorines instead, and that which makes it polar, because hexane would be a non-polar molecule. Perfluoro-hexane would most likely be polar. But yes, 1.669 grams per centimeter cubed. And water are immiscible liquids. Okay, so it doesn't give away the density of water, but we do know, I guess from literature, that water density, okay, is, let me actually just write in a different color because it's not given, but it's something we should know. Something kind of to memorize, unfortunately. It's kind of like typically in the standard temperature and pressure, it's 1 gram per centimeter cubed. That is the density of water. Okay, maybe our physics classes will have that. I doubt it though. Let's see. Oh, yep, density of water. Nice. This is a different sheet though, but 1.00 grams per mole in standard temperature and pressure. So let's see the other pieces here that they say. They don't dissolve in one another, so they will form layers. And you place 10 ml of each in a graduated cylinder, along with pieces of high density polyethylene. Okay, so this is a solid. Okay, HDPE, density 0.97 grams per centimeter cubed. Okay, that's a piece of it, right? Not just another liquid. Polyvinyl chloride. Okay, chloride. Okay, PVC, and this is 1.36 grams per centimeter cubed. Okay, and Teflon, 2.3 grams per centimeter cubed. None of these common plastic dissolves in these liquids, which is good. Describe what you expect to see. So the rules of density, okay, are that the heaviest will sink, the lightest will float up top of it. Okay, so what we're going to do is just first label it. We want to label, we're going to use I guess different colors to try to make it look as different as possible. So we're going to do like a shift. I'll explain what I mean by that. The lightest one here in terms of density will be the hexane. Okay, density of 0.76. So we're going to label this as green hexane. Okay, and now perfluoro-hexane is going to be labeled as red P. I might just have to use different colors actually, just for this one. Yeah, perfluoro-hexane, that'll be P. Yeah, okay. C6F14, as they've given this nicely. Whoops, that wouldn't be it. Actually, it wouldn't matter. I don't mind that actually. Okay, and then water is going to be 1. So knowing this, actually, let's start with that. It's 10 mils of each, right? So because the perfluoro-hexane, as you see, is the densest, it'll be at the bottom. So if we had a graduated cylinder, right? Okay, that's what it says. Yep, in the graduated cylinder we have 10 here, 20 here, and 30 here, right? The first one would be, let me just make this actually black so there's no confusion. The first one at the 10 mark, okay, would be that C6F14 of perfluoro-hexane. That'd be the thing that's all the way at the bottom. Okay, water will be the next one because that one is 1.0 grams, which is greater than 0.766 grams per centimeter cubed. Okay, and the last one would be the hexane. Okay, so now we kind of have to pick some really bold colors here, because now we want to show where each of the plastics would be. So let's pick purple for HDPE. Okay, density is 0.97, so it is greater than the hexane density, meaning it will sink right through, but less than the water, meaning that this thing would be a solid right there on top. So this is HDPE right there, solid on top of that, just like that. Okay, and now with that being said, okay, the polyvinyl chloride, okay, is greater than water but less than the perfluoro-hexane. So we can choose this color, for example. This would be now PVC. Oh, that's like what they use in pipes. Oh, that's not a good color. Let's use a different color. Let's use something that stands out from blue, orange. That's a good one. I hope I'm correct. So that's better. So it's going to be sitting right on top of the red. Okay, and now Teflon. Let's actually just go back to black to make it a little bit easier for us. Okay, Teflon, and you notice it's 2.3 grams per centimeter cubed. So that thing will just sink right to the bottom. It's denser than any of the liquids. So this is where the Teflon will be. Okay, and just like that, you can actually now see we have a full picture here of what you would expect to see when you put these three liquids together along with those three plastics. Okay, let's see how we did. Hopefully they have an image. Nice. Nice. So exactly, A, HDPE. Whoops. Yeah, HDPE is hexane layer. Yep, that's what we have. And then next, the PVC is floating in the water, exactly like right on top of the perfluoro-hexane, and Teflon's at the bottom of the graduated cylinder. Okay, and Teflon is dense, so it will sink further than the perfluoro-hexane. So we have it correct. We have hexane, water, perfluoro-hexane, HDPE, polyvinyl chloride, and then we have the Teflon. Okay, this is correct. That was quite enjoyable. I like drawing that picture, and it really shows exactly like how densities work, and also kind of emphasizes how chemistry and physics are not